Electropermeabilization is a process of using pulsed electric fields to increase the permeability of the cell membrane in order to allow the uptake of exogenous molecules. If careful and precise parameters are adhered to, this permeability is temporary, with little long-term effect on cell viability. While this is not strictly the creation of physical pores in the cell surface, electroporation is a more common and indeed easier to say terminology. It did not take long after this phenomenon was first observed to appreciate that this was a useful tool to enhance the uptake of drugs that would otherwise be blocked by the cell membrane. There have been many different drug delivery methods like viral vectors, liposomes and lipid-encapsulated nanoparticles, and the more advanced polyplexes and micelles. These all combine the desired drug or particle with a specific delivery vehicle that is able to penetrate the cell membrane. However, with electroporation, the cell membrane is in effect opened up temporarily to allow any drug that may be present to enter the cell. Hence, unaltered traditional drugs can be used without the need to combine or complex them with complicated and expensive technologies that can also have side effects. Gene therapy with IL-12, PD-1 peptides, DNA and RNA particles encoding a variety of proteins, along with a multitude of drugs, can be delivered using electroporation. The use of chemotherapy to treat cancer, with drugs like bleomycin and cisplatin, that otherwise would have poor cellular uptake, introduce the more specific term electrochemotherapy, or ECT. Electrochemotherapy has been used in veterinary oncology for the last 15 years. ECT devices from Europe led the field, reliably delivering pulses of around 1200 volts per centimetre, as had been established in the early work on veterinary electroporation, mainly out of France and Eastern Europe in the 90s. Whilst effective, this level of delivered energy often had the undesired side effects such as large areas of tissue necrosis. Clinicians taking a more conservative approach to treatment would see more incomplete drug delivery to the tumour cells, requiring a greater number of follow-up treatments. In order to improve the safety, tolerability and efficacy of ECT, scientists and biomedical engineers at the University of South Florida, who have spent over 35 years pioneering electroporation in the US, developed novel patented technologies that LifePulse Bioscience incorporated into the VetPulse 2000. These are the addition of concurrent moderate heating and the monitoring of the extent of poration using real-time impedance feedback. Understanding these modifications is key to understanding the VetPulse procedure. Before you start the procedure, you will need to decide which is the most suitable electrode to use. At the moment, VetPulse offers 4 different types of electrodes. The plate electrode should be used on scars and incomplete margins. The electric field generated by these plates penetrates around 3 to 4 millimeters below the surface of the skin and in between the plates. This means they may be suitable for small tumour nodules that can be bridged by the plates. When treating gross disease, no deeper than around 15 millimeters, needle electrode should be used. There are 3 versions available. The 7.5 millimeter gap electrode delivers 450 volt pulses to a larger area and can be used in larger tumours with more docile patients. The narrower 5 millimeter electrodes deliver 300 volt pulses over a smaller area, more suitable for small dogs and cats. Finally, the 4 needle electrode can be used for small tumours, especially in difficult to reach areas like nasal or oral sarcomas. Place the chosen electrodes onto the handle before you turn the device on. To do this, undo the screw top, place the electrode gently in the fitting, it only goes one way, then gently replace the screw top. The electrode is spring loaded, so the screw needs to be snug, not over tightened. Just to be clear, when discussing ECT voltages, the device operating voltage is given per centimetre, but the delivered voltage may be different and depends on the distance between the 2 electrodes. The VetPulse 2000 operates at 600 volts per centimetre for canine and feline procedures, therefore the 5mm gap needle electrode delivers half of this, which is 300 volts. Now we are ready to start the VetPulse 2000. This can be done as the patient is being prepared for anaesthesia or sedation, giving it some time to warm up. Make sure the handle cable is inserted into the two sockets. No twisting is required, just insert the plugs straight in, ensuring the plugs align. Plug the power cord into the rear of the device and turn on the main on-off switch on the device. You should hear two beeps. Turn on the computer, log on to the computer using the device serial number as seen on the screen. Click on the VetPulse icon if the app hasn't opened automatically, sign in using MMD admin and press next. Check that everything looks good and the handle slider is set to off. Press the one silver button on the front. The heating element and the fan in the handle will turn on. This preheat takes 2 minutes, but you can leave it for longer to ensure that it is warmer. Hence, starting 10 minutes before the procedure works well. When the animal is ready, place the electrode onto the starting point on the scar or tumour. So, where is that? One of the side effects of ECT is a phenomena called vascular lock, whereby blood perfusion is decreased and the chemotherapeutic is in effect locked into the tumour. Based on this knowledge, it is better to work inwards in decreasing concentric circles from the tumour margin. To start the procedure, we will need to warm the target tissue up to 43 degrees Celsius. This concurrent heating system ensures that although we are using a lower, more tolerable voltage, the generated electrical field is still enough to permeabilize all of the cells within the field, including those furthest away from the electrode. Lower energy causes far less tissue damage and requires lower levels of sedation, so this waiting period to heat the tumour is well worth it. Move the sliding button to the on position to initiate the heating process. Hold the electrode against the tumour or insert the needles into the tumour and hold it there. There is an infrared camera located behind the electrode that measures the surface temperature, which is indicated on the screen. Once it reaches 43 degrees, the second sequence of 30 seconds is initiated. This is designed to allow the heat to soak into the tumour. Be patient. Once this is complete, we can begin electroporation. Press and release the pulse button. 2 beeps indicates pulsing, 3 beeps indicates the required pulsing sequence is finished. This sequence is not always the same length of time, leading us to explore the second novel technology, the concurrent measurement of impedance. Reversible electroporation is based on many variables, altering the transmembrane potential gradient enough to allow permeability is dependent on the voltage, here it is set at 600 volts per centimetre, the pulse length, which is set at 100 microseconds, and the number of pulses. Traditionally, this was always set at 8 pulses. The problem with this system of fixed parameters is sometimes you don't need all 8 pulses to achieve maximum paration. It depends on the tissue composition, which is invariably extremely heterogeneous. Therefore, applying all 8 pulses automatically is efficient, but increases the risk of side effects. More importantly though, there is no system in place to stop you from repeating those 8 pulses in the same region, causing further tissue necrosis. For this reason, a conservative approach bordering on undertreatment tends to be the procedure of choice. With the VetPulse device, in between each 100 microsecond pulse, the technology switches circuits to emit another far lower energy pulse lasting for 10 microseconds. It uses this pulse through impedance spectroscopy to measure the change in impedance, which is the inverse of resistance, after each pulse. It detects when the change in impedance flattens out, indicating successful electroporation. At this point, the device will stop pulsing automatically, avoiding over-treatment and the damaging side effects. This means that if you do think you missed a small area, you can go over it again within a 30-second time frame and repeat the pulse. The device will pulse or not pulse depending on the level of perforation it detects. This approach decreases the risk of incomplete treatment. So, we pulse, we get 2 beeps, then 3 beeps. Position the electrode perpendicular to the previous position, hold it in place for 5 to 10 seconds to add to the heat that would have disseminated from the previous pulse area, then press the button again and repeat, covering the whole tumour and the margins. In between pulses, the device begins a countdown of 2.5 minutes until it shuts off safely. If you need to repeat pulsing but require a longer period of waiting time, moving the slider off and on again resets the timer. Once you have finished the procedure, just press the silver button on the front of the device and everything will turn off. Safely dispose of the electrode, close down the LifePulse program, turn off the device and the computer, and that's it. With regards to patient recovery and post-ECT care, one can expect a small amount of edema. If the plates were used, very little further intervention will be required. However, if needles were used, then covering anti-inflammatories and pain meds will be required. Expect some scab formation from the necrosing tumour tissue and some tissue damage, though again this is more from the needle trauma than the ECT itself. The patient should feel comfortable immediately and results should be seen within 2 weeks. Further treatment requirements can then be assessed. And that is modern electrochemotherapy. At LifePulse Bioscience, we do believe that this technology will help the hundreds and thousands of dogs and cats that are unable to benefit from radiation therapy due to cost or accessibility. With the new developments, it is hoped that ECT can become a major use modality in the battle against cancer. Thank you to you and your oncology team for leading the way and your ongoing commitment to animal health.